Hello everyone, today we're going to do example 4.2.1 located on page 32 of your textbook, and this is the pair series problem. As you can see here, which is also located on page 32, I've entered some generic information. I've given a title, my name, the school, and the date. I've also entered some coefficients. We have gravity, the mass, coefficient of drag, and initial velocity, as well as a couple others. We also have this table, which we're going to use throughout the problem. So to start the problem, you should enter in all this data. Next, you want to select cell A6 and highlight down to B11, and then go to the Formulas tab. Go to Create from Selection, and then click Left Column. This is basically assigned all the variables that we have right here to its respective number in column B. Once we've done this, we want to go into cell B14 and then enter this equation. V naught times exponential, which you do exp, in parenthesis, minus CD divided by m times A14, close parenthesis, plus G times M divided by CD times parenthesis 1 minus exponential parenthesis minus CD divided by M times A14 again. Then we'll close both parentheses, hit enter, and as expected we get a value of 0. This is a simple formula. It's equation 4.1 in your book. This calculates the velocity of a parachuter jumping out of, or just falling. Velocity of a parachuter falling. So this is without a chute. So simply, once we've entered this formula, we can double click on the bottom right hand corner of cell B14 to get the rest of our values. This value of 47.5 is correct, as noted on page 33. So now we want to create a plot. So we go to Insert, Scatter, and we'll choose this one so we can track the change in our between our points. So click this. Alright, so you can see we have a blank graph here. So right click on the graph, click Select Data, go under Legend Entries, click Add, and we'll want our X values to be time. So I'll highlight from A14 to A20, and then our Y values will be our velocities. Alright, so that's what that should look like, and you can also give it a series name, because we're also going to put another line on this graph, and it's really important to do this when you have multiple lines on the same graph. So we'll call this V no chute. Click OK, and click OK again, and we have our graph. Now to make it nice and neat, you can come up here under Chart Tools, click Design, and then I always choose this option, Layout 1. It allows you to give it axes. So we'll give it time, and it's in seconds. And we'll give it velocity, which is in meters per second. Okay, so we've created the first part of our graph. And now we want to go into Visual Basic, because right now what we've done is an easy function for Excel to do. You can do this all the time. But now we want to find out what the velocity is with the chute. So you go into Developer, and then enter Visual Basic. Alright, and then we want to insert new modules. And then from here we want to enter in the code on page 34. So we'll start, we're going to do a function, or a function macro today. So we'll do function. vel, and we're basically just selecting all our variables. So t, comma g, comma m, comma cd, comma v naught, comma tc, comma cdp. Alright, and you can see that once you hit enter, you have Visual Basic creates the function for you, which begins and then it inserts the end function. Now from here we want to define everything, so we'll do single quotes to define what we need. So we're going to tell what it is, so function to compute velocity of falling parachutist. Okay? We're also going to say before and after pulling the ripcord, which is basically just deploying the parachute. So now we'll define our variables, or identify what they are, I'm sorry. So t equals time, and it's in seconds. G is just the gravitational constant. That's in meters per second squared. M is the mass, and that's in kilograms. CD is the drag coefficient, and that's in kilograms per second. V naught is the initial velocity of the parachutist, and that's in meters per second. Oh, see, you can see I forgot to give it a single quote, so it didn't identify it. So once you do that, you should be all set. Give it a single quote again. TC equals the time when the ripcord is pulled, and that's in seconds. And finally, CDP equals drag coefficient after ripcord is pulled, and that's in kilograms per second. Alright, next we can start writing our code. So I give it an extra space. So we're going to start with an if statement. If t is less than tc, then, and we're going to define what that is, so give it a single quote. Compute velocity for free fall. Then hit enter, and we're going to type in